when we talk about quality, first we have to look at the real quality of the fat. I'm talking about the safety and about peroxidation and oxidation. We know dogs and cats, they are really strict to those feelings. So cats are more than dogs. They can feel the oxidation easily than other species.
Hello, this is Dennis Jewell with the podcast on pet nutrition, and I have the honor of having Dr. Trevizan here today. We are going to talk about lipids, and I'd like to invite you to come in and join us. We were chatting before we started. We both have a lot of common ground in this area, and it's very important. So, Dr. Trevizan, if I could you tell us a little bit about yourself and how you got to this place, and then we'll do the deep dive into the lipids.
Yeah. Thank you, Dennis, for the invitation to be here. It's a pleasure. So, I got my DVM on, it was in 2003. Then I at vet school. Then I switched to the master's directly. And at that time I was studying amino acids requirements for growing dogs. Then I jumped to the lipids when I went to my PhD or my doctorate, actually. And it was part in Brazil and parts at Texas A&M University. Then I started getting closer to the lipids metabolism. And since that time, I finished my graduate course. Then I was hired by the university here in Brazil, and I became professor, and I am professor until now. So and like professor, a full professor in Brazil, we have to teach classes. We have some part of extension as well. And the rest of the time is for research. So research is optional, but you can have time on this. And most part of the professors here, they are involved in research.
Corbion's Algaprine, DHA-P3, the algae-based omega-3 DHA to boost brain, cognition, immune system, and well-being. Adding it to pet food is easier than ever. Cut out the middle fish and go straight to the natural source to enjoy all the benefits of omega-3 DHA. It's better for the planet with zero impact on the ocean and low carbon footprint, and it's easy to use. The highly concentrated biomass powder is suitable for multiple applications. Learn more at corbion.com.
Well, it's very exciting to have you with us today, and I sort of have to smile. I think many academics speak of the same thing you had with, teaching, research, and some sort of extension, which I hope this podcast will sort of count as. Certainly many people might be interested in your work and learn about it through this podcast. Well, let's talk about, we'll just start in the basics. Fats fascinates me because it is one of these requirements that also influences subsequent metabolism. But let's just talk about the basics for a little bit. I mean, how does one define fat quality, and is there really differences depending on the fat that we see in the pet foods?
Well, when we talk about quality, first we have to look at the real quality of the fat. I'm talking about the safety and about peroxidation and oxidation. So we know that dogs and cats, they are really strict to those feelings. So cats are more than dogs. So they can feel the oxidation easily than other species.
So they smell those oxidative byproducts like hexanol or whatever is coming out. They probably won't even eat the food then if it's oxidized. Is that right?
Exactly. That is the first. I think is the first parameter we have to take in consideration when you include a fat source in the diet. And also, we have different sources of fat. And of course, dogs and cats, they will prefer animal sources. And between the animal sources, we have different acceptation as well. So I think first is the general quality that we have to take in consideration. And we have some parameters that you have to accept on the lab analysis to include those fats into the diets. But I'm a little bit more worried with the fatty acids concentration in those fats.
So let's talk first. Let's talk first about safety. I like that classification you gave, and then maybe we'll set it aside for the rest. So we have to have fats that's not rancid, and we can tell that by low peroxide value, low offsets like hexanol that's coming off of rancid fat. I have to smile. I understand that humans might not be quite as antagonistic, quite as sensitive to this rancidity. I used to know a friend who worked in the potato chip industry, and he said, hey, a little rancidity, people kind of learned that that's what potato chips taste like, and they sort of like that. And I don't think our pets are that way at all. They just don't like rancid fats. So.
Yeah, it's true. I completely agree with you, because probably our sense is less accurate than the sense of dogs and cats. It's because probably the number of the cells that we have inside of our nasal cavity and the amount of neurons that leaves our mucus and reaches to the olfactory bulb are greater than the number of cells that we have. So it makes much more complex the smelling in dogs and cats, because they are much complex than our perception. So they can in a small amount of particles that you can volatilize from the food, they can perceive different smell. But for us, it is not that precise.
Yeah, you did open up something I wanted to ask you about, and we should chat a little bit, in that fats are stable, kind of dependent on polyunsaturated numbers, right? So DHA is a lot less stable than palmitic acid or something. So high number of unsaturated in those like fish oils, or as we know, the fish don't make them. They're algal oils that the fish eat. And so do you have to, or do you recommend someone, if they're putting these less stable oils in, that something different should be done for the sort of physical antioxidants in the food?
That is a really important question, because people are looking for some food that doesn't have any like antioxidants inside, like artificial antioxidants, BHT, BHA, and other antioxidants. But can you think about the oxidation? If you don't have those components, probably the fat could be oxidized, and if it's oxidized, doesn't have any value anymore. So that's really important to concern about these questions. We have natural antioxidants, but for those type of fats, like you said before, like polyunsaturated fat, they are more prone to be oxidized, because like we know that when you have a double bond, the adjacent bond is fragile, and it reacts more with free radicals, and it is a reaction in chain. So we have to prevent in the beginning that oxidation. So like fish sources must be prevented, and other sources that contains especially Linolenic acid is one of the fatty acids that oxidize more easily. And of course, DHA and EPA, because the number of double bonds are greater.
Well, that's interesting, and it's very important for the food scientists and the nutritionists to deal with this. My hope is that the consumer doesn't need to, that the food scientists and nutritionists have put together an antioxidant package. There's good methods of testing oxidation, that they know that through shelf life, this has full stability. I would just sort of tell people that it's not always true. And so I've smelled, you can smell those volatiles coming off and think, I would not feed that. That's just no longer a good food.
And also we have other ways to prevent at the during the processing at the end of the chain. We have to prevent the oils for against the oxidation. Then the oil will go into the feed formulation. So in the feed formulation, you have more antioxidants, and then we can prevent the consumption of the antioxidants when you change the atmosphere, when you have a better package, like
nitrogen flush.
Exactly.
Yeah, seal it in nitrogen. It's not going to oxidize. Well, that's great. Well, let's set that aside. It's really important, and hopefully, people think about it and they make a formulation that fits for their intended purposes. We sort of touched on these very different types of fat. EPA is not like alpha-linolenic, and yet it's more like alpha-linolenic than it is palmitic. So can you just walk us through a little primer on how we look at different types of fat?
Well, I would say that all types of fat are usual. So we can make use from all of them, but you have to adjust the way we add it in the diets. So some type of fat, vegetable fat, dogs and cats don't like that much.
Yeah, it's less palatable. I'll smile with you and maybe try and build on that. Say, they still might like vegetable fat better than carbohydrate, but they sure like animal fat better than vegetable fat. So
yeah, but if you compare, like soybean oil is really palatable for them. So we have tested here soybean oil, and it's palatable. But like if you include palm oil, for example, that is the most common fat in the world, probably other fats would be more palatable than palm oil. So yeah, so we have to choose. But why you use palm oil? Well, sometimes if you want to increase the diets in fatty acids, in saturated fatty acids, just to fill the diet with energy, can be one of the ways to do.
And I mean, we should talk about chain length too, right? So you want to talk a little bit about the medium chain triglycerides you might find, on that side versus the normal long chain versus the very long chain. So it's very complex. It's the chain length and unsaturation that define then how the pet will use it. And I think, it's worth a chat, right? This is a complex space.
Yes, it is. I think that is one of the important points on the lipids metabolism, because volatile fatty acids, they are consumed by the mucosa, and part of them will be absorbed to the bloodstream. But medium chain fatty acids, they have different type of absorption, because they are more water soluble. They do not go into the the chylomicrons. Like when you digest medium fatty acids, that comes from coconut and other palm trees. So those fatty acids are the medium chain. I am talking about 6 colon 0, 8 colon 0, 10 colon 0, and part of 12 colon 0.
But never 14, right? So you're looking at carbon length of these fatty acids, and you would define a 14 as not medium chain anymore.
No. It's not.
Yep.
It's not. And partially, we concern about the 12 because the 12 carbons, just part of them, they accept the same way to be absorbed. Because part of the 12 carbons seems like they goes into the chylomicrons. They are not going directly to the liver. That was I was talking before, and the medium chain fatty acids, they goes directly to the portal vein, and they goes directly to the liver, and they do not need like the complexity of the absorption is not in those fatty acids because they are more soluble, so they goes directly to the liver, and they don't need carnitine to get into the mitochondria. So burns really fast. But the long chain fatty acids, they have specific digestion, so they will need lots of steps, like they pass through the mouth, they have some lipases in the mouth and the stomach as well. Then they will need biosalts, they will need lipase, and then they will absorb, and they will be absorbed just in a monoglycerides or...
So they present as triglycerides, 3 fatty acids on a glycerol backbone, and then they're getting this monoglyceride, which is actually what's coming through the gut, right? So that's what's being absorbed.
Exactly. So the enterocytes, they will have the triglycerides inside them because they rebuild the triglycerides, and they have to make the package. And the package is made with triglycerides in the middle, and we have phospholipids around to make that bowl a little bit more soluble. Then we have cholesterol, and we have some proteins in there, and that is a huge molecule. So it goes directly into the lymphatic vessels. And the lymphatic vessels didn't take the lymph to the liver. It goes into the chylocistern, and after that, thoracic duct, and goes to the cava. Is cava caudal cava. I don't remember the name of the biggest vessel.
Vena cava.
Yeah, but I mean, goes directly to the heart. And so the long chain triglycerides, they will reach the heart, and after the lungs, then the heart again, and after that they will go to the rest of the circulation, and will reach the tissues first. So if rest some triglycerides, they will go back to the liver. So it's different, the way to metabolize those fatty acids.
I'm seeing that we're going to have 2 talks. We're going to talk this safety and sort of basic metabolism first, then I'm going to cut off in maybe another 10, 20 minutes. We're going to jump into the deeper metabolomics of these different fatty acids. So while we're here, let's talk a little bit about organ specificity, because like the butyrate fatty acid, the enterocytes are loving that, right? Not a lot of that's even getting through. And then you got these medium chain triglycerides, which I understand like kidney and heart, they're very happy to burn those guys up and use them as energy sources. But then the carnitine dependent ones, these long chain fatty acids, that's more muscle and the heart uses everything, of course, but there's quite a difference in metabolism that you're talking about depending on this chain length.
Yeah, that is really important to know how they are metabolized, because in certain pathologic cases, you can adapt to the diets with those type of fatty acids. So I'm not talking about the short chain fatty acids, because they are more related to the intestinal production.
I mean, you can feed them, right? You can feed short chain fatty acids, and you can promote them through glycolytic metabolism of the bacteria.
Yes. Our soluble fibers, like fermentable fibers, they will be source of those fatty acids. But most part of them, the enterocytes or the colonocytes will use, like the butyrate, for example. That is great. But if you have some cases and when you don't want the large amount of triglycerides going to the lymphatic vessels for some reason, we can use like short chain fatty acids in this case. So like it's different routes that we can use for reestablish the metabolism of the animal.
Oh, let's do a little deeper dive into that too, because I've played with trying to push the pets towards a more ketogenic sort of place where the ketone bodies come up and their beta hydroxybutyrate coming up, and there's a whole human nutrition side where people are finding some neurological or other benefits towards this kind of really strange fatty acid metabolism. How do you feel about that for pets, as long as we're into this deep dive into the metabolism energy component of fatty acids? Is that something you have investigated? What do you think?
There is a diet in the market that uses that principle. So they used to include in the diet some medium chain fatty acids, and when those medium chain fatty acids, they supply lots of energy directly to the liver. Medium chain fatty acids, glucose and amino acids are really fast absorbed. So it's around 30 minutes after consumption, you will have fatty acids going to the liver. So with that amount of fatty acids in the liver must export part of the energy. And part of the energy can be exported in form of beta hydroxybutyrate. And they use that principle to include those medium chain fatty acids in diets for old dogs that have some neurologic transtorns. And it is a paper published by Penn in 2012. And they said that they got a really nice improvement in old dogs with those diets. It is makes sense because the neurologic cells in the central nervous system, those cells are not able to hydrolyze glucose at those levels of energy that the brain needs when those cells became older. So when beta hydroxybutyrate reaches those cells, it's easier to metabolize and generate energy. So they notice when they feed the dogs with this type of diets, the dogs had some improvement in cognition. So I think is one of the way you have to start thinking about the fatty acids. I think we just have to recognize the individual effect of each fatty acid. It's not clear yet because some people read that information and they said, oh, I will add coconut oil in the diets. So it doesn't work. It doesn't work in the same way because the type of fatty acids that were included in that diet were different. So the amount of caprylic acid, and caproic acid are different than the composition that we have in the coconut oil.
I mean, a lot of coconut oil is high in C14, right? I mean, it's not even medium chain triglycerides.
Exactly. Yeah, and yeah, C12. I think is the most part of the coconut fat is like in the medium fatty acids is related to the 12 colon 0.
Yeah. Fascinating. Well, I really think there's a tremendous. I've published a couple papers with medium chain triglycerides and looking at their interactions with other fatty acids. So, I really think you hit on something so important to think. Well, we have to look at this fatty acid profile as a complete unit, a bit different than maybe how we used to think about fat, which was more or less as an energy source and as a aid in uptake of fat soluble vitamins. I mean, it was required for a reason, but this secondary metabolism associated with dietary fat intake I think it's just really ripe for lots of research and deeper understanding that we don't have yet.
Yeah, especially in dogs and cats. We have some in humans and rats and mice, but and in the plate cells, like
Yeah, of course.
in vitro, but we don't have those studies yet in dogs and cats, and I think that is I think we want to research in the future. Probably we'll need some research in this area, especially when we individualize the fatty acids. The fatty acids, they work by itself, and each fatty acid, I believe, has its own function, but they act together as well. So
Yes.
it's not easy to understand them, but I would say it's easier than study protein metabolism, for example. Because when you add protein in the diet, you never know what's going to come out from the enterocytes to the bloodstream. And when you add lipids, it's more stable. So lipids, I used to say that people that study lipids are happier because we can see the effects on the tissues. So if you look at the tissues and you can recognize the diet that animal was eating before.
This one, let's talk about this idea of requirements versus optimum and set down first for us, what are the requirements for fat in dogs and cats? And then we'll smile and say, well, optimum.
Yeah, well, the requirement of fats is really low. Like if you're concerned about the fatty acids requirement, like the amount of fat that you need to supply that is very low, I would say. It's really easy to supply those fatty acids with a small amount of fat.
So we're talking like a requirement of maybe 5% of the diet, the minimal for fatty acids.
Less than it.
Well, when we set it for AFCO, we set it at 5%. So I'm going to give us a little bit there.
Yeah, I think they take in consideration that you're using like practical ingredients. So in a practical diets, probably you have to increase a little bit more. Like 5% would be nice to supply all of them. But if you have a purified diet, you just
understood.
Need
and so what are we looking at for the metabolism? Like, for example, we struggled with, when do we put the omega-3s as essential? I think we sort of backed into it by wanting a ratio in the adults, and then in the younger pets, we said, okay, we want some EPA, DHA. How do you feel about that with requirements?
Well, that is a really tough question, because to take that decision to include more than the amounts that the requirements that has been established in NRC or the requirements that the guides for practical diets has been wrote. I believe that we don't need like a huge amount of fatty acids in those diets.
Yeah, for the difference between requirement and optimum always. So probably what you're telling me is if you go out into the store and you buy pet food, you're going to see, a dog product at, 12, 15, 17% dry matter fat, and the cat probably higher. You can your feeling is you can pretty much safely assume that that's enough to supply life and reproduction and the classic required for life things probably met in that diet. Is that what you're telling me?
Yes. As long as they supply the essential part of the fatty acids, the rest of the fat is just for energy.
So let's talk about essential. So you would put the 18,2-linoleic, because which then they make arachidonic acid from, and of course cats need arachidonic acid as well. Dogs can build it fairly well from the precursor, and then I maintain for that reproduction and early growth that you get a great benefit. Even why we made it essential to have some DHA. Because it's just really hard for the pet to make enough to have, optimum mental capacity and retinal capacity and those sorts of things. Would you agree with that? Sort of put my stance down, but what do you think?
Well, yes. We have a lot, like part of the fatty acids are functional. So they have function. And some specific tissues, they have a greater concentration of some specific fatty acids. Like the retin, for example, has about 30% of DHA. And the brain has lots of DHA as well. So some tissues will be how can I say? They will be helped by those fatty acids when you supply in the diet. If you have some pathologies, for example, and then the ratio between fatty acids seems like has some role in those pathologies, and the ratio between fatty acids and the amount of fatty acids that we include in the diet will be will have lots of different. Will make lots of difference in those diets regarding to the pathology that has been target for those kind of diets with high fatty acids. But if I'm talking about the regular dogs, like adult dogs, that they are normal and they are just are in feed to reach the minimal amount of the basal requirement of energy, the maintenance requirement of energy, the minimal amount that is established in RC should be enough.
Well, let's end with this idea on the ratios. When you said ratios, did you have specific ones that you like? I assume you're thinking omega-6 and omega-3 ratio or other ratios. Do you have a ratio or a concentration of those that if I really like to see that in dog and cat food?
Well, in regular diets, we have, if you take from the NRC or from the most part of the guides for animal nutrition, you'll have a ratio between omega-6 and 3 about 30 to 1 or less than 30 to 1. But when I do feed formulation, I used to maintain the ratio between those fatty acids between 10 to 1 and 5 to 1. I think the closer ratio seems like to be better, but we still have evidence that is good, but we don't know yet what is the best way to measure that ratio. In dogs, for example, we know that linoleic acid and linolenic acid can be desaturated and elongated. But in cats, for example, seems like it doesn't happen because of the absence of delta-6 desaturase. So when you take in account all the fatty acids, in dogs, I would say in dogs, I am prone to say that is better than in cats. So when you take the ratio between all the fatty acids together, and also we can make the ratio between linoleic acid and linolenic acid. There is something important in those fatty acids, because linolenic acid, when you increase the amount of linolenic acid, there is some publications that report reduction of delta-6 desaturase action on the conversion of linolenic acid to gamma-linolenic acid. So yeah, we have some impacts in there. And also it happens on delta-5 desaturase. When we increase the amount of EPA and DHA, delta-5 desaturase tend to reduce the desaturation of D-homo-gamma-linolenic to arachidonic acid. So I think we have to go a little bit deeper in those researches, because I think we have some start point, but we didn't get at the end.
Well, that's fascinating. I think it's worth a whole new session. I hope that we can sort of this one say, look, we've talked about safety, we've talked about requirements, and a little bit of deep dive into optimum. But I really like the idea of spending significant time talking about optimum. You know, we really haven't talked about what's excessive and what we might have challenges for future research, for the balance that optimum has to be balanced at some level. And we haven't even talked about source. You know, I've become sort of enamored with the idea that, you know, we like these omega-3 very long-chain polyunsaturated fatty acids, and we might be overfishing a little bit to get them. So algal solution to that seems to be important, and maybe we can talk about that in our next one. We'll set that up, and I would love to take a whole session and talk about that. I think it's worth it if we could.
Yeah, should be nice.
Okay, thank you. Thank you for your time today. I found this a fascinating discussion, and of course it's interesting to me. It's an area of research that I think I marvel at the beauty, if you will, of being able to understand the metabolism of the pet as it shifts in response to these dietary fatty acids. It's just remarkable. So thanks for delving into it with me.
Yeah, thank you too.
So let's sign off, and we'll chat again soon, I hope.
Yeah, thank you so much.